Hello everyone. Today we are going to learn about recoverability. We have been talking about concurrent executions and the potential problems associated with it. And we have also seen that whenever transactions are executing, there may be a situation when halfway through some unwanted incident has happened. It may be power failure or system crash, due to which many a times to maintain consistency the transaction has to be reverted back, that is abort. You cancel because we have atomicity property which says either all or none. So it has to revert back. Now situations where you are capable of revert back and get back to a consistent state in case of failure is called as recoverability. Okay, what is it? It refers to the ability of the system to restore to its state to a point where the integrity of the data is not compromised, especially whenever failure or any error occurs. Now, we know that when multiple transactions are executing concurrently, issues may arise that may affect the system's recoverability. Now, that is, it can result in a scenarios where transaction effects cannot be undone, which would violate the system's integrity. So, in order to maintain the integrity and consistency of the data, we require recoverability. That is, integrity of the data might be compromised if we are not able to recover, because of which the business processes may get adversely affected. That in turn may make you to lose the trust of end users. All these things are the problems which may arise if you are not able to recover the database. For simple example, you are transacting money through your GPay or something like that. Sometimes it will so happen that money gets deducted from your account, but it has not reached the beneficiary. That means unless and until that amount is recovered back, you will not have trust on the bank's database. You will never do online transactions anymore, right? So this is what is importance of recoverability. What are recoverable schedules? Now, a schedule is said to be recoverable if any pair of transaction Ti and Tj, if Tj reads the data that is earlier written by Ti and Ti commits before Tj, then I say that that schedule is recoverable. That means there should not be dirty read, what you have earlier understood. Look at this particular situation. There are two transactions T1 and T2 in this schedule. Now T2 reads the data object A, which is earlier written by the transaction T1, okay, but in the mean course what you see is T1 has committed before T2. Now what happens? Whatever data T2 has read, it is assured that that is the perfect data because T1 has committed. There is no chance of aborting or otherwise roll back. So there is no dirty read. That is why this is a recoverable schedule. What is an unrecoverable, non-recoverable schedule? In case of transactions Ti and Tj, if Tj reads the data which Ti has earlier written and Tj commits before Ti. Look at this, T1 and T2, and here we see that T2 commits before T1. So if T1 also commits, there won't be any problem. But in case if T1 fails, if it has to reverse, if it has to revert back, roll back, then the data which is read and updated by T2 is going to be nonsense. That doesn't exist at all. That leaves the database in an inconsistent stage, which is not good, or this is a non-recoverable schedule. There can be certain times cascading rollbacks. What is this? This is when we have got this kind of situation where I have read the transaction or I have read the data which is updated by another transaction before it gets committed. So in that case, if there is, look at this situation where we are talking about T1 has updated something which is read by T2 before it could get committed. So now T2 reads that data, maybe T2 will write it to the database also, whatever may happen. But during the course of time, we see that T1 got failed. It has to abort due to atomicity property. It has to roll back. Now this rollback also affects T2. So the T2's rollback is dependent, or there is certain other dependent rollbacks. This is what is called as cascading rollback. One attached to the other. It is like your nested loops where one after the other it is continuously performing. In that same way, one after the other it has to rolled back. So cascading rollback occurs when the rollback of a single transaction causes one or more dependent transaction to be rolled back. Though the situation can occur when you read an uncommitted data. So later transaction fails and it needs to be rolled back, automatically the associated or dependent transactions will roll back. So this is cascading rollback. We have cascade-less schedules. That means you will be reading only committed data, no dirty reads. Then automatically, if any particular transaction rolls back also, you need not have to roll back the dependent transaction which has read, because it has read only after committed. After committed transaction cannot fail. So it is in between which may happen. So only that transaction fails, only that gets rolled back. Look at this. A schedule is considered cascade-less if transactions only read the committed values. This means in a schedule, a transaction can read a value written by another transaction only after the later has committed. So cascade-less schedules prevent cascading rollbacks, so they ensure data consistency. Look at the transactions here. Only after T1 has committed, T2 is reading the updated value of A. So it will not get affected. Well, so this is regarding the recoverability concept, how we are going to implement this locking and see this recoverability things or isolation implementation we will see in our next video. Thank you.